it goes. Today and tomorrow, that's it. Then this channel will be fabricated into other content creation stuff because this is no longer necessary. So we got this thing. I mean, this one's a bit harder because we got LG in the actual power. Like, will I actually have such an exercise? Perhaps I should skip this one. So, now this. I'm gonna need exercises like on the bloody test. No fucking bullshit. So we got this thing, and the binomial coefficient of the third term is 6 times bigger than the binomial coefficient of the almost last term. Show that the representation of the 7th term divided by the 8th term is essentially a whole number. Okay, so let me think about this. So first of all, of the second term, the coefficient binomial, that's just Cn2, as it's Cnk, the formula, and k is essentially 2, as it's 2 plus 1 for 3. And that is 6 times bigger than the one of the last one. So it's written like this: 6 times, obviously, and the binomial coefficient of almost last one, perhaps not called like that, but fuck it, I don't call like that. It's essentially this: Cn and a power n minus 1, because it's n almost the last one. So whatever, like stuff like this. So now we just kind of solve this, find out n, and then plug it in into T7 and divided by T8, and show that this representation is a whole number. So first of all, solve this, which is going to be n times n minus 1 in parentheses divided by 2, equal with 6 times, right there is kind of harder. So it's gonna be first thing first, and on what's gonna be on top, an exclamation mark. Bro, fucking, I like how this fucking guy's videos fucking cut off. And minus 1, so that's just n, huh? That is just n. Well, I guess this can be deducted, so let's just get on with it. Minus n equal with 12n, so basically it's crisscross, and n at the second power minus what, minus 13n equal with 0. And after this we put the n up front, right? Doesn't even fucking put the n up front. Moves too fast, bruv. And 0 and n minus 13 equals 0, right? So n is 13. So n has to be bigger than 0, so n is essentially 13. So we found out that successfully. And now we move on, right? N is 13. Okay. Now we have to calculate G7 and G8 and do the division. Like I said previously, C13 obviously because that's 13, and the K is 6 because it's 6 plus 1. And now we work with those terms that we have provided right here. It's gonna be A at the A. Why A? Or just give A power of 7. Why A to the power of 7? Well, I get it that it's the 7th term, but B power of 7, B power of 6, what? Man, what kind of tricked off stuff is this? Will we actually have something like this? Why A7 and B6? Well, K, right? 13 minus 6 is 7. So just denote it as A and B. That's the reason, I think. Understandable. Now what? We do the same thing for T8? Or we just calculate the C? So this is T8. It's gonna be A at the power of what? A essentially at the power of 6 and B power of 7. Okay. Now what? We need to determine the middle for some reason. Which is n divided by 2, which is going to be what? 13 divided by 2, but you cannot do that. It's going to be 6 or what? What do you mean 6.7? It's 6.5. Or 6 and 7. Two terms in the middle right there. I guess that's how it works. Man, this is fucking fucked up. So gotta be plus 1. So what now here? 7.5. So 7 and 8. But what the hell are you doing? C36. What do you mean for C36? From where'd you get a free? Anyways, let me get fucking skip this. Whatever. Fuck this exercise. Let's see. I made this probability video. Is it something good here that I actually need to watch here? Let me see the problems here. Bro, this probability stuff I kind of already went over with, so I'm gonna find something else better. Found this fucking test. Should be the best video to watch right now. So basically first exercise and so on. I never watched this video. And yeah, it's completely new exercises. And I'm gonna skip the ones that I don't want to watch. 27, that's 3 power 3. And the power gets multiplied with the other power, 2 divided by 3, so it's gonna be 3 at the power of 6 divided by 3, which is gonna be 2, so 3 power 2, 9. And then plus the other thing, that is essentially, so first you flip it, and you're gonna get 16, so 9 plus 16.
Abbiamo.
Like super easy, bro, for me. No need to watch the formula table, you don't even have formulas given here. So now, second one, with imaginary numbers. So basically I have to find the complex number z with form a plus bi, I to the second power minus 1, for which the matrix is not inversible. So not inversible means it's equal to 0. Inversible not equal to 0. So basically crisscross, negative, boom, and you're done. Perhaps you're gonna have to do some quadratic if you have to. There are multiple methods here, I think. So first find this, solve this, crisscross like I said equal to 0. So z plus zi minus 2 equal to 0. Looks like here the method chosen is moving the 2 to the right, and now I think he's gonna divide 2 by 1 plus 1, which is this gonna be z. Or actually no, he's gonna just plug in a plus bi. So now we're gonna have to multiply, I think, a plus ai plus bi to the second power equal to 2. So we're gonna write down the same thing, but now instead of bi to the second power, write down minus b plus ai plus bi equal to 2. Now we just work with imaginary, non-imaginary parts, right? So a minus b is going to be equal to 2, and a plus b equal to 0. And so we just get a value that we want, plug it in. We're going to have, 2a equal to 2. Which is correct, right? 2a equal to 2. Doesn't really make sense, because shouldn't it be that 2a is gonna be equal with 2 divided by minus b, and like that b is minus a. Well, yeah, that makes sense. Anyways, a is 1. What kind of method is this, bro? Anyway, z is 1 minus I. Now this fucking equation, we got the square root. I think under the square root we just pop it bigger or equal to 0. So this guy actually didn't start with DVAs, he started this, move the x to the right. And I think it's gonna do everything to the second power, or I don't know what it's gonna do. X bigger or equal to 0, and x plus 2 bigger or equal to 0, right? I don't know what matters this, bro. I'm just gonna skip this. Cos, obviously, skip this in the fastest way possible. In equation, this one's quite hard, so fuck it. Geometry, I don't know. Maybe we'll watch it a bit. So we got this parallelogram. So A60 degrees, AB is 4, and the diagonal BD is 2 square root of 7. Find area. So first of all, we can do the Pythagorean and just find AD, and from there, I don't know the formula of area. And what is this 2AB? Man, get the fuck out. Fucking cos. Cos your fucking gas. This one's fucking hard. Fuck this. Fuck this. Should actually... What the fuck is this fucking lines? Fucking... Get the fuck out, cos. Fucking cos your fucking ass. This one, fucking monotonia. I think we need to go with fucking limits. Limit till n infinite, stuff like that. Yeah. That's what this one's about, as far as I know. So basically x n right here. So you just plug in 1, plug in 2, find out which is bigger, do limits of till infinite. There's gonna be infinite on infinite, stuff like that. Yeah, that's what I think it will be. M plus 1 minus 1 right there. So 2n plus 2, 2n plus 1, and 2n plus 3. Plug in minus 1 and plus 1. What the fuck is this method? Fuck you. No. I'm not gonna fucking put up with this. This is too hard. Fucking exercise 10, I'm not even gonna fucking think about watching it. It's just fucking stupid math. Look at it. Limits. Who the fuck cares about this? I don't care about this. This integral especially. Now this is what I'm talking about. Probability. Okay, so there's a survey, obviously, and there are 25 pupils in a class. 2 are taken for the survey, I suppose, and the probability that at the survey 2 girls will participate is 11 divided by 50. Determine the number of girls in a class. So here, first calculate the total number of n cases. So 25 people, let's take 2, so C 25 2, boom, calculate that. So calculate this first, 25 times 24 divided by 2. Why? Because below we're gonna have 25 minus 2, 23, so boom, boom. So we're gonna have 25 times 12. And how much is that? That is 300. So now we know that n is 300. And what else can we do here? We have a probability that only 2 girls will participate is 11 divided by 50. So should I just write down 2 circles? How the fuck is this one made? CF2. So 2 are taken. 2 are taken, and that's why 2, and F is just like their kind of X, and then you equalize this with 11 by 15 to find out that's what is perfect, perhaps, but did we also, was it necessary to calculate the n, which is 300? Anyway, so we got this f minus 1, and below what, 2 equal with 11 divided by 50, right? Oh, actually m divided by n is 11 by 50, so now we know n, we know m, plug it in and stuff, so we can work from here. 50 times m equal with 11n. Okay, get that now. 50 times that expression and 11 times 300, which is how much? I don't really know. 15300, we can actually just cut it. So we're gonna have 6 on the left, so 66 there. 11 times 12, because of a 2 right there, we took it away. And so on the right, I think we're gonna have 132, and on the left, obviously, f to the second power minus f, so perhaps some quadratic or viet or some other stuff. F is 12 or what? So you just go like this. I mean, this is fucking advanced. This binom. Perhaps I did something similar, but I'm not really that sure, so just fucking do it for a bit. So find the term that doesn't contain x. So I actually have to calculate the term, and first of all we have n. So plug in formula. X parts of the powers we equalize with x power 0, right? And then we move on. Formula right there, every formula what you need. Plug it in. 50 minus k, and that add the power of what? K. Now this equal C15k right there. X to the power of 1 divided by 3 times that power. No problem. So that is going to be 15 minus k divided by 3, and now this we can do minus 1 to the power of k, and there 1 divided by square root of x to the power of k, or what? What are you going to do? That. So x square root over there is x at the power of minus 1 divided by 2, so it's going to be x at the power of minus k divided by 2. Okay. So we just move the minus 1 power of k out of there because we work with a x term, so we don't really need the other stuff. So now we can just write down what we have, and the minus 1 power of k right there, and now x is just going to be at the power of 15 minus k divided by 3 minus k divided by 2. So now we work with that power. We just essentially get the same denominator, so multiplied with 2 to the left with 3 to the right, and equal with what? Equal to fucking 0. So that's great, because we are equaling it with x to the power of 0, so we're then equaling the powers, so we get this. And we're gonna have essentially just the same stuff, but not divided by 6, and on top it's gonna be 30 minus 2k minus 3k, so 30 minus 5k equals 0. So k is gonna be 6, so I think I did something like this, so I mean, I'm just gonna fucking skip it, find another fucking video. We got this BAC 2023, so perhaps this is a good video. Probability 2022, that could also be a fucking good video. I'm fucking tired of this shit. I told you, today and tomorrow, that's it. No more. No more math for life. 1.5 right there. Minus 2 right there. So, powers fucking multiplier. We're gonna have 3 of power 3, which is fucking 27. Minus 2, that's 25, fucking 5. Fuck you, fucking easy exercise. And now this fucking easy, bruv. I did 10,000 of this fucking exercise, so I'm gonna fucking just skip this one and tired of this shit. Now this one, fucking in equation, I mean, kind of fucking did this stuff, in equation with fucking powers, but I think it can fuck up a bit, so let's just fucking do it. And I think DVA right here is not fucking necessary, so let's just do like this. 0.25 is fucking 25 divided by 100, so that is 1 divided by 4, power of x plus 3. So we can do that, so okay. And right there, 2 power 3, 2 power of x. So basically the main thing is to fucking get the base of 2. So 1 divided by 4, boom. How'd you write down a base of 2? You write down as 2 power of minus 2. Minus 2 multiply fucking that. So I did kind of fucking 10,000 fucking exercises with this fucking thing. So we get this, we equalize fucking powers, we fucking switch like fucking x goes to fucking left and stuff, right? So minus 3x is gonna be equal with 9. So you gotta switch like this. So switch like this. So x is gonna be fucking minus 3, right? But actually we don't fucking calculate what it's gonna be, just minus 3 is smaller, so x is going from minus 3 till plus infinite, with a minus 3 included, so easy as day. Sine, obviously skip that with fucking lightning speed. This fucking equation, double EVA, fuck this. Fucking pi, geometry problem, I could fuck you. And now this 2 divided by 3. I mean, I could try this fucking AF exercise, so fucking hard, so fucking cost, so that can go fuck itself. Now this mathematical analysis. We got B3 is 20, B6 is 160. So we gotta understand how it goes. So B6 is B5 times the ratio, so that is Q, so that is also B4 times the Q times B5, right? Or times Q again. Okay, so that is, now we get to B3, right, and stuff. So B4 Q times Q to the second power times what? Equal to B3 times Q times Q to the second power. Okay, so this is how kind of fucking expression, how it works. It's pretty fucking fucked up. I think there are fucking number matters too. So basically, you know B6, you know B3, so kind of you fucking write it down in a way that allows you to use fucking both values. And this is what you fucking get, B4 Q, Q. Because B5 is B4 times Q. And so Q to the second power, so B4 you write down as B3Q, so Q to the second power remains. So just fucking need to calculate Q. B3 you fucking know. B6 you fucking know, so 160 equal with 20 times Q in parentheses, or not, times Q to the second power, so 160 equal with 20Q to the third power. That's what it is. So Q third power is gonna be equal with 8, so Q is fucking 2. Okay, so now this fucking exercise 10, fucking limits, whatever. So you see it's fucking complicated. I'm not a math geek, so I'm gonna just fucking skip this, obviously. Okay, now probability, let's go. So, probability. There are numbers 1, 2, 3, 4, 5, 6. And 4-digit number is formed, probability that the three first digits are not fucking 246. You know what I mean? And the digits are separate, twice identical. So basically, they should be only 1, 3, 5, 6, 7, 9, and so they should also only contain this, and they should be like 11. I mean 1, 1, 3, 3, 5, 5 in that fucking order. That's how they should be. So basically, calculate probability that out of all the fucking numbers you take 4, and they're gonna be exactly like this. Okay, so this one's a bit hard, but it's probability, so I'm kind of G at this. So obviously we start off with formula m divided by n, and n total number of cases. We've got how many digits in total? 6. And basically we form a 4 digits number. So we just do C, right? Or not C. Combinations or arrangements? Bruv, I think fucking arrangements, right? Because the order matters in the fucking number, so 6 below and 4 above. Right? Let me see if I'm fucking right. So basically start off with fucking the table and so on, so let's try to fucking guess the M. The favorable cases, I'll calculate that. So, I guess it's calculating the n though with this fucking thing. So take 4. So firstly it can be 1, 2, 3, 4, 5, 6. The second one, it can be also that, but without 1. So it's actually 4 exclamation mark, right? Or is it? Out of 6 you take 1. Okay. 6 power to 4, huh? 1296. Okay, so it's actually 6 power to 4. Fucked up. Fucking fucked up probability problem. Whatever. 6 power 4 it is. Now let's go fucking calculate M. Right? M, yes, 4 squares like that, and the first one, it can either be 1, 3, 5, 7, or 9, or no, it can be 1 and 1 and 3 and 3, or it can be 5 and 5 and 7 and 7. We need to populate like all of the fucking things, right? 1, 3, 5. Oh, but fucking it's like this we take from the fucking 1, 2, 3, 4, 5, 6, right? So it can only be until 6. So the only numbers that work are 1, 3, 5. Yeah. So why'd you fucking put P3? What is this, Formula 1? What is this? P3 times what? Bro, fucking condition. Fucking condition. It's super hard, bro. Super hard. The fucking thing is, the 3 digits, only they must be 1, 3, 5. The other ones, The other ones are 2, 4, 6. Hold up. Other ones are 2, 4, 6. Right? So if the other ones are 2, 4, 6. And they must be distinctive 2 by 2. What that fucking means? How is this even possible? Bro, this was super hard. Super hard. Should I actually just skip this because it's too hard? P3, I guess, kind of get it, like 3 exclamation mark, first ones. Can switch around, but the condition says, like, they should switch around 2 by 2, so I thought 3 and 3 and then 5 and 5, but actually it's not that, so what it is then? That is M, that's it, that's M. Out of 3, take 1. Probably I'm gonna say fuck this fucking thing. 6 times 3, 6, 6. Fuck this fucking thing, bruv. Fuck it. So we got this. Essentially. Problem 12. Right. Find the middle term of this disvoltation, knowing that the sum of binomial coefficients is 1496. Okay, brother, I think I'm a genius. I'm gonna be able to solve this. First up, you calculate the n using formula sum of coefficients, so means 2 of the power of n equals 1496. So you think what 2 at what power gives you 1496? That is 2 at the power of what, 12? So n is 12, right? So n is fucking 12. And now you just plug in this into the general formula and solve from there to find k. But here you don't like fucking work like before. What you get x in the power, you equalize with 0. You don't work like that here. Here it's a bit different. Right here, essentially, you just have to find the term in the middle, so you divide n by 2 and plus 1, and to find the term in the middle, right? So it's going to be 7, right? So k is 7, as far as I understand. And then you have everything, you just calculate it. N is 12. But there are 12 plus 1, so it's T7. So basically my formula worked, I'm a genius. T7, so T6 plus 1, yes. Now, what you need to do is pop everything in, because you have pretty much everything. C below is going to be n, which is 12. And on top we're going to have 6 times x at the power of 6, and there the same stuff at the power of k, which is 6. So C, the same stuff remains like this. Actually it's going to work it a bit. So it's going to be like this for now. And x to the power of 6, and right there x to the power of negative 1 divided by 3, so it's x to the power of negative 2. When we flip it, and right there we're gonna have 7, 8, 9, 10, 12, 11 also, and below 2, 3, 5, 4, 6. So we simplify and multiply accordingly. We can pop it like x divided by 2, so in terms of a power is going to be x to the power 4 right there, and we just need to calculate that and write down till the end t7 is equal what we get like right here. So 2 and 4 simplify with 8, 3 simplify with 3 and 4 with 12, and 6 with something else, whatever, how you want it. 3 right there, 8 right there, and right there 2, and right there 5 and 10, right? 7, 3, 10, 7, 3, 2, x power 4. How much is that? That's 21, 42, 84. Yes, and how much is that? I don't fucking know. Perhaps like something like 906, 924 x4. So T7 is 924 x4. That's what it is. Boom. Now, like I said, I got this probability video. Let's check it out. Okay, so here it goes. Here fucking goes. This fucking thing was in 2008. So there are 50 fucking watermelons sold, and 40 are ripe. What is the probability that buying from here any 2 watermelons are ripe? So that's the condition right here. Okay, so how to do this? And basically calculate like the same fucking stuff. Total number of terms, favorable terms. So with total 1, you got 15 total, and you take 2. So that's that. C52, right? That's the n. As far as I know. Yeah, I'm a genius. C52. And calculating this is going to be essentially 49 times 50 divided by 2. So that is 49 times 25. So that's 1250. Minus what? Minus 25. So that's 1225. We got the n. Right. Now, let's calculate VM. Which is obviously fucking harder. So, to calculate Vn, the M, just pop fucking 2 circles representing the 2 watermelons we're fucking taking. So, first one So for the fucking first one, it's gonna be C of 40 and 1, and the second one times that also. But we took one, so C39 on one, so I think 40 times 39 is gonna be the M, right? Man, pretty sure it's that. What? It's C42? It's that easy? And 40 times 49, 40 times 39, how much is that? Was I kind of right? 40 times 49, 1560. 40 right there, 39. It has to be divided by fucking 2. God damn it, so I guess I wasn't a bit. I fucked up just a bit. Okay, so 18 right there. 20 times 39. So how much is that? 780. 780. So probability is 780 divided by 1225. We can simplify by 5, so 78 write down like this. 1225 we can write down 5 times 5 times 7 times 7. So 5 5. Now that's it. So 16 divided by 45. Okay, genius. In the best way. This is 2009. Right here. There is a candy box, and in it 6 candies are white, 6 are yellow, and 8 are brown. What is the probability that when you take 2 candies, they will be fucking brown? That's the condition. So here, obviously, you just, you know it, mates. You do the same stuff. So the total number of cases, first, I'm gonna calculate it. So how am I gonna do that? On top, what do I have? Essentially on top, but no, on top we don't need. We just take 2, so C, 2 on top, and below the total number of candies. So 6 plus 6, 12, plus 8, 20. So C22. Boom. Headshot. That's that. So I got 20 times 19 divided by what? Divided by 2, right? So it's gonna be 190. Easy as cake. Now we calculate the bloody M. So, calculating the M. Thinking about this. So to calculate the M basically it's pretty much the same as before. Is it just as easy as this? C of 8 2, right? Bruv, it's easy as this. 8 fucking 7 fucking 2. So we're gonna have 28. Bro, fucking easiest problem ever. 7 times 4, 10 times 19 or whatever. 19 times 5 2. Simplify that, we get 2. So 14 divided by what? By 95. "2014 test with flowers." Kind of just a bit remember this, but perhaps no, so let's just do it. Fucking Jesus. There's a vase with white flowers and red. The number of red flowers is 3 times larger than the number of white ones. Okay. 2 fucking flowers are taken. Find the probability that the flowers taken... No. It's actually given. The probability that the flowers taken have different fucking colors. So, you take 2 flowers, so obviously there are flowers red and white, so you took 1 red and 1 white. And probability of that is 10 divided by 21. So what you need to do is understand the initial numbers of flowers within the vase. So the total number of flowers, not just fucking red, not just fucking white. All of fucking flowers. Okay, so this. This is basically how it's solved. Well, I think... So, like, from what I remember, m divided by n is 10 equal to n divided by 21. Yeah? So, we need to find the initial one. So, we need to find n. So, we kind of need to calculate the m using some formula. And then crisscross it and solve it. Yeah, this is what we need to do right here. So, yeah. Calculating essentially the m. Well, we can fucking interpret that. So the main condition here is that the number of red flowers is 3 times larger than the number of white flowers. Bro, this one's fucking fucked up. So really fucking fucked up. The previous one like this. But this one is hard as fuck. So, if I note the red flowers with X and the white flowers with Y, I'm gonna have X is equal to 3Y. Bro, just gonna fucking watch this or what? Should I fucking just watch this? Not fucking try so hard to get it through. X, white flowers. Oh, bro, right here it's not actually 3x. Right here it's x plus 3 because it's with 3 times more, not by 3 times more. So that's that. White and red we have them. X and x plus 3. So in terms of M, you write down 2 circles. And yeah. And pretty much first circle. First circle. It's gonna be like you take C and then of x and you take 1 and then times C of x plus 3 and you take 1 formula and that's it, I think. In total it's 2x plus 3. What? What? Total is 2x plus 3. X and x plus 3, so x plus 3 is 2x plus 3, yeah? So n is going to be kind of in a formula form. C of 2x plus 3 and you take 2, right? That's what I think it is. Okay. So now just fucking do it. We will have 2x plus 3 exclamation mark right there. But it's actually written as this, so that we can simplify, I think. So we're gonna have 2x plus 1 and then 2x, or what? Why'd you go like this? Why'd you write down twice like this? Okay, so below you have 2x plus 3 minus 2, so that's 2x plus 1, exclamation mark, so kind of that's what it is. Okay, so kind of I get it. And now you just multiply every term on top and then you divide by 2 and you get what you get, right? That's what I think it is. 2x plus 3 on top, and we take the 2 up front so that we can cross out the 2 and we can just multiply 2x plus 3 in parentheses with x plus 1 in parentheses. That's what I think it is right here. Yes, that's what I think it is right here. Okay. Get it. Now it's gonna be 2x to the second power plus 2x, right? Let me see. So it's gonna be that form. It's not gonna be touched, I guess. Now in terms of bloody m, like I said, x take 1 times c of x plus 3 take 1, right? So it's going to be essentially x times x plus 3, right? Genius! Now we have n, and I'm using the x form expression, and we equalize that with 10 by 21. So x times, in parentheses, x plus 3 divided by 2x plus 3 parentheses times x plus 1 in parentheses is going to be equal to 10 divided by 21. That's what it's going to be. M divided by n right there. That. So just crisscross it and find the value. X plus 1 equal if 10 divided by 21. Okay. So I'm looking at the problem below right now, and I kind of something similar like I fucking did, but kind of no, so let's just do it. Yeah. It's gonna be alright. Just do this one, do another one, and today and tomorrow, that's it. So x to the second power plus 3x, all of that times 21 equal with everything, right? 21x, so we can also go like that, and then that to x to the second power, so we're gonna remove that initial double parenthesis, and we're gonna multiply and so on. 2x to the second power plus 2x, right, plus 3x plus 3, like so. Now 21x to the second power plus 63x. Bruv, you forgot the x, didn't you? I think you forgot the x. Perhaps gonna understand later when he will find out that he got the wrong fucking answer. Right now, 21x to the second power plus 20x plus 30x, so that's essentially just 50x plus 30. So we're gonna add some quadratic and we're gonna get the result, or what? Like, come on, quadratic right here, I guess. So 50x x to the second power minus yx to the second power, because the x to the second power moved to the left, so we got this. Now I told you that he fucked up with a fucking 63. Should have also an x right there. But for now he's gonna write down what? Minus 50x, and then plus 33. Equal of 0. So that's pretty fucked up, right? 63x, there we go. There we fucking go. So now we are gonna have minus, oh no, plus 13x minus 30. So okay, so that's better. Now using what? V out or delta we solve. X is basically 2. What? X is 2? I mean, I guess we can skip it like this. So if we plug it in, it's gonna be 4 plus 3, which is 7. So yeah, if we plug it in, it's gonna be 4 plus 3, which is 7, right? So that's this. Now you have to solve this problem right here. Okay, so there are 20 computers and 4 have a hidden defect. 3 were bought. Find the probability that at least 2 computers of those bought are without fault. Okay, so this is the problem right here. Understandable. So obviously it's not like the previous one, it's a bit easier. You don't have to equal it with stuff. You just have to essentially do it like this. You have the n and VM, obviously. N is going to be C of 20 and 3 because there are a total of 20 computers and you buy 3. So that's Vn. Calculating this, we're going to have 20 times 19 times 18 divided by 3. So it's going to be 20 times 19 times 6. Actually, times 3 because there's also a 2. It's a 3 exclamation mark, not just 3. So 190 times 6, which is 1140 right here, bruv. We have the 1140 right here. Okay, now moving on. What we can do, we need to calculate VM. So to calculate VM, you just do 3 circles representing the 3 computers you bought. And after this, what? At least 2 computers to be without fault. So you just write down like plus is computer without fault, minus is with fault. So plus plus minus, that's probability. Minus plus plus, or plus minus plus, or plus plus plus. Those are all the cases. So 4 cases in total. And for the plus 1, you write down the C. And for those without defect, there are 16 because 20 minus 4. So when it's a plus, it's C16 of 1, right? And as you have already taken one, for the next one is going to be C15 of 1, and for the last batch, minus 1, it's going to be times C41, which is essentially 4. And yeah, plus with other cases and work like this, so that's it. That's it as far as I know. That's the approach right here. So kind of you don't fucking know here. Kind of you don't fucking know. Because this guy right here that shows the solution said it doesn't matter whether you take the computer with the defect. I mean, whether the first computer is without defect and then the second without defect and third is without defect. I mean, with defect, doesn't matter. So there are 2 cases only. So now we just calculated like before, but only 2 cases. C16.2 times C15.2, right? Or actually, no. Bro, I fucked up again. It's C16 too because obviously you have 16 and take 2 and you can just work like this. Yeah. Pretty much. And C for 1, obviously that's 4. And then plus C 16 free, right? Okay, so we got this. 16, 15, below, we have 2, right? Times 4 plus what I have right there is 16, 15, 14 divided by 3, 2. And the 1 is fucking necessary. I don't even have to write down. 16, 15. So that's gonna be 8 times 15, which is 120 times 4. 480 plus that whatever, it's 35 times 16 there. So this 80 times 7, 480 plus 560, so that is how much? That is essentially 1,040. So as you can see, the simplification, you just remove a 0 and you can simplify once again by what? By 2 of course, but I don't know if you can do higher. 52, 57. So yeah, probability is quite high. We got this. Okay. So we got this problem right here. Obviously this one I pretty much kind of remember doing it. But let's do it again for fuck's sake. So I mean essentially, bro. Fucking, you have a fucking coin, right? So the coin has the bill sign and the whatever sign. And it's from 5 times. And you have to calculate probability that the whatever sign will fall 2 times. Exactly, 2 times. Okay, so to do this, obviously m divided by n. Total number of cases, what is that? Well, there are 2 sides, and you throw it 5 times, so it's 2 power 5, I remember this. So this is 32, total number of cases. And for the favorable cases, it's a bit harder, obviously. You've thrown it 5 times, so you just do 5 circles or 5 squares, whatever. And after you've done that, in first one, it can either be, so we can do like this. We can denote that the whatever sign is check mark and the bill sign is X, and we can do 2 check marks and 3 X's, or 3 check marks and no, No, 3 X's and 2 check marks there at the end. Like right here. Does it actually matter when it's gonna fall? Is this necessary to understand? I think it actually matters here. Like, I mean, if it matters, if in the first row is gonna be whatever sign, and the second one, essentially the bill sign. But if you write down everything, it's gonna be quite a long list. So, perhaps you do with C. I don't really know. C of what? Of fuck this, let's just fucking watch it. And obviously it's easy, 32. But if M is super hard, how am I supposed to know it? Yes, 5 squares, whatever. Yes, so the S represents whatever, in my case. So C5 of 2 because it's from 5 times, 5 slots, and 2 need to be with whatever. And the rest of them, it's C5 of 3 or what? Or just C5 of 2? Bro, fucking fucked up, whatever. 5 times 4. Yeah, and below we have 2. So it's gonna be what? It's gonna be 10. So probability is 10 divided by 42. Simplify that and so on. You will have right there below 5 divided by 16, right? Alright. So let's get this done. We got a casino one. I mean, not casino, just lottery. There's a lottery. And there are 100 tickets. And 10 tickets have a 200 lei winning prize. 20 have a 100 lei winning prize. And the rest of them have nothing. Find the probability that you will win 200 in total if you buy 2 tickets. Okay, that's it. The same as before. Here the N is not going to be 2 at the power of something because you're not throwing a coin, you're buying lottery tickets. So here, in total there are 100 lottery tickets and you take 2, so C102, so that's pretty easy. I can just show you how it's done. 199 divided by 2, so 50 times 99. 50 times 9, 11. So 450 times 11. Bro, this is some fucking fucked up shit. So 4,950. I'm not gonna fucking get deep in matters of how to fucking solve this quick. Just fucking solve it and fuck off. 4,950. Now we have to calculate VM, obviously, which is fucking harder. To calculate VM, you just write down 2 circles, right? 2 squares. And basically the probability of the total winning sum to be 200. Total winning sum to be 200. So you either buy 1 200 lei winning ticket or 2 100 lei winning tickets right? So these are the cases. So you have to buy 2 tickets. So either buy one not winning ticket and one that wins 200 to have a total sum of 200, or 2 tickets both 100 value. So for this, you just do it like this. C. You just think about how many tickets win you 210. So you take 1. C 10 1, so that's 10. In first case, 10 times what? Times the C of the rest of them, and take 1. So the rest of them, 13 total are winning ones. So 100 minus 30, 70 are not winning ones. So you're gonna have 10 times 70. That is 700. So you get 700, and then plus the rest of them. So 20 of 100. So C22. That's it. You should get M. I'm pretty sure that I've solved this correctly. Yeah, I'm pretty sure about that. Yeah, this is basically your set of probabilities, and C10-1, which is 10 times C71 plus C22. So right there is 10 times 70 is 700, and there it's 20 times 19 divided by 2, which obviously is 190. So that is 890. Write it down correctly, simplify, and so on. You're gonna have 890 divided by this right here, and 89 divided by 495. Just remove a 0. It looks like it's no longer simplifiable, and we have received this sum. Well, I think I already did this one, so I'm gonna skip this one. Skip this one for now. This one right here, well, basically, I think I did something similar, but just like this, no, so we're gonna do this. But for now, we're gonna have to go a bit, so I think pause for now. Yeah.